In this lesson, we're going to talk about integration in the inverse trig functions. It's pretty much a shorter lesson. These are only 3 examples, and I want you guys to write down what's in the box up there. These are essentially the backwards of what we talked about yesterday, where instead of taking derivatives of the trig functions, we'll take the integrals of them. Notice that we only have sine and tangent up here. The reason we don't have cosine is because sine and cosine are pretty much the same integral, just negative versus positive, so we'll just include both of those to be sine, and then we'll account for the negatives later. And then for tangent, it's up there. The other ones, though, can be made as well from combinations, and so these are the 2 main ones we would need to know. So essentially, if you look at these integrals, our job is to be able to determine what a is and what u is in each of these, and then plug them into the right-hand side to actually write the integral. So in this first one, notice it has a square root in the bottom, so that looks more like the integral of sine than it does of the integral of tangent. And I'm looking for an a value being squared and a u value being squared. So my a value that's being squared is 1, so I'm just going to write a equals 1. My u value that's being squared is x, so I'll just write u equals x. Notice that if I plug them in here, I get 1 over, a squared, which is 1 squared, minus x squared. So that's what I have here. And then I'm just going to plug them into the right-hand side. So it's sine inverse of u over a. So that's going to give me sine inverse of u, which is x, over a, which is 1, plus c. So that is the integral of this problem. For this next one, again, it looks a lot like the integral of sine because we have a square root on the bottom. My a value this time is 2, and my u value is still x. Again, because if I plug those into the function, I get 2 squared minus x squared, which is 4 minus x squared. So if I look at the right-hand side, that would be sine inverse of u, which is x, over a, which is 2, plus c. And last but not least, this one does not have a square root in the bottom, so I don't think it's sine. I think instead it's tangent. So my a value is 1. My u value is x. And if I plug those into the right-hand side of the equation, I get 1 over 1 times tangent inverse of u over a, which is x over 1, plus c. Final answer. So obviously you can have different combinations in here, besides just 1s and 2s and things like that, and different combinations for x as well. But those are just the ones that I wanted to show you. Alright, so real short video for today. That's the end of it.